Hi guys, welcome back. We've just started our lesson on parallel lines, so we're going to finish off now and talk about perpendicular lines. So let's jump in. I've got two lines here that are perpendicular to each other. So perpendicular just means that they're at right angles. When we looked at parallel lines, we knew that their slopes were the same. We're going to compare that with the slopes of the perpendicular lines. So let's start having a look at this red line here. So we can see that this red line here is a positive slope. I would also say that this line here is a very flat sort of a slope. Now, the perpendicular line, so the line that's running through at right angles, you can see, and this is going to be pretty obvious, is the negative version of this red line here. What might not be so obvious about the slope is that if you were to compare the slopes, while this is a slightly positive slope, its reciprocal here is very, very, very steep. It just happens to be going in the opposite direction. So this is how we've come up with the formula for our slope. If we were to call this particular line here line 1 and this particular line here line 2, then this slope here will be called M1. And the slope of this line here is going to be M2. So the first thing that we noted was that this particular blue line was the negative version of the red line. And the other thing that's, again, not as obvious is that this very mild slope here becomes a very steep slope when it's going in the opposite direction. So it actually becomes the reciprocal of that slope. Okay, so let's talk about this in real life. If I was to call this, or say that this particular red line here had a slope of, let's say, 1/4. So it's a very, very shallow line. And I wanted to determine what this line here, or the slope of this line here, is going to be. Well, first of all, it's going to be the negative version of this, and then it's going to be the reciprocal of this. So let's substitute it into our formula and see how this works. So the slope of M1 is going to be equal to 1/4. M1 is also equal to the negative reciprocal of our other slope. So 1/4 must be equal to -1 over M2. And so if I rearrange this, I'm going to multiply both sides by 4, and then I'm going to multiply both sides by M, then I'm going to get M2 is equal to -4. So in other words, the slope of this line here is going to be equal to -4. And we can kind of see that. That kind of makes sense because this is a very shallow positive line and its reciprocal or its perpendicular line is going to have a very steep negative slope. All right, so let's have a go at this question here now. Show that the lines y is equal to -5x plus 2 and 5y minus x plus 15 are equal to 0 is perpendicular to one another. So the first thing that I'm going to do is I'm going to get them in slope-intercept form so that I can actually compare the slopes fairly. Now this one here is already in slope-intercept form, so I don't need to mess around with him, but this one here we're going to rearrange. So we've got 5y minus x plus 15 is equal to 0. So I'm going to move the x over to the other side and I'm going to move the 15 over to the other side. Once I've done that, I'm going to divide through by 5. So this is how I got the line. Y is equal to 1/5 x minus 3. So we're going to see now if this particular slope is perpendicular to this. And we're going to check that using our formula. So our formula being M1 is the negative reciprocal of our second slope. So we're going to call this our M1 value. So -5 is equal to -1 over M2. And we're going to see if we actually get 1/5 as our answer. Now what I'm going to do is I'm going to multiply both sides by M2. Okay, and then I'm going to divide both sides by -5. So I get M2 is equal to 1 over 5. So we do get that. So this particular line here is reciprocal or is perpendicular to that particular line there. All right, so I want you to have a go now. So when we write this, we're going to write this in a particular way. So I've got a line here, AB, and I've got a line CD, and these are the points that we are given for that. So I'm going to determine if they're perpendicular or not by using that same method that I've just done. So I'm going to work out the gradient first. So this line AB, I'm going to call this point x2 and y2, and this is going to be my x1 and my y1, and I'm just going to use that gradient formula that we've used a few times now. Okay, and then I'm going to substitute those values in. So 8 minus 6 is going to be 2, and 3 minus 1 is going to be 2. So the slope of this particular line is going to be 1. If it was going to be perpendicular to this line here, CD, let's substitute into our formula and let's actually work out what the perpendicular slope would be. So M1 is equal to the negative reciprocal of our second line. So 1 should be equal to negative 1 over M2. Now if I multiply both sides by M2, then my gradient for my second line should be equal to negative 1. And if it is equal to negative 1, it's perpendicular. All right, let's find the gradient of that second line now, so the line CD. So for this one, I'm going to call this one's going to be my point 2, and this one's going to be my point 1. So again, we're just going to use that formula, y2 take y1 over x2 take x1. Now, this is going to be 1 take away negative 6, which is going to be 7. And then we're going to have negative 3. Negative 3 take away 4 is going to be negative 7. So my gradient for this particular line is going to be negative 1, just like we thought. So these lines are perpendicular to each other, and there's a special way that we write that. So the line AB is perpendicular to the line CD. All right, so what I want you to do now is I want you to have a go at B, C, and D for me and just making sure that you're using this particular notation. Now, if it is not perpendicular, then we obviously are not going to write that. We'll just write that A and B are not perpendicular to each other. Okay, so we're going to go through how to do the same thing now, but for horizontal and for vertical lines. Now, we can't use our formulas for horizontal and vertical lines, and I'll show you why. So let's take this horizontal line here. The slope of this horizontal line is equal to 0. So let's write that M1 is equal to 0. So let's try substituting this into my formula now. So if I write M1 is equal to the negative reciprocal of M2, effectively what I would do is I would multiply this side by M2 so that I get M1, M2 is equal to negative 1. By the way, that's a nice little quick way to double check is that if you multiply the two gradients together and you get negative 1 as your answer, then they are perpendicular. So that's just a quick check. It's a little bit off topic there, but let's just jump back in. So now I'm going to go through and divide both sides by M1. So M2 is equal to negative 1 over M1. Now let's substitute in our values. So I know that the gradient of that line is going to be 0. So M2 is equal to negative 1 divided by 0. We can't do that. We can't divide by 0. So now we're starting to see the problem with just assuming that we can just dump stuff into a formula. So we've got to be a little bit smarter about it. So find the equation of the vertical line that passes through the point 2, 3. I'm just going to draw this and I'm just going to come back. So just quickly drawn this here. So this is my graph and this is my point at 2, 3. And I want to find the equation of the vertical line that's passing through that point. So as you can see, if I could actually draw this properly, which, sorry about it, it's not very tidy, but it is what it is. So if I wanted to look at the equation of this particular vertical line, I know that because it's a vertical line, it's probably going to have a formula that is x equal to a constant. And because it doesn't actually matter what the value of y is, I know that it's always going to go through x is equal to 2. I'm just going to write that as my formula. So really simple, x is equal to 2. Now, if I wanted to find the horizontal line that passes through the point negative 2 and 6, again, I could quickly draw that. So again, we can see that if I draw this here, we've got a horizontal line that's going through that point of y is equal to 6. And it doesn't matter what the y value is going to be. So we could just write that, I'm going to write that in blue, as y is equal to 6. So it's really simple. Effectively, all you're doing is you're just looking at the coordinate. So the vertical line, it's going to be x is equal to something, and in this case, x is equal to 2. For the horizontal line, we know that horizontal lines are y is equal to something, and so for this one, we're going to just say that y is equal to 6. Very, very simple. All right, so I want you to have a go now. I want you to find the equation of some vertical and some horizontal lines. So I'm going to get you to pause this, and I'm going to go through question 12 with you. All right, question 12, very simple. It's a vertical line. So because it's a vertical line, we know that's x is equal to something. So I'm just going to look at this x coordinate here, and I can just write this line as x is equal to 1. Very simple. Same thing with the horizontal line. Because we know horizontal lines are y is equal to something, I'm just going to look at the y coordinate, and it's just going to be y is equal to negative 7. Very, very simple. All right, there's a few multiple choice questions here that I want you to have a go at. I'm not going to go through the solutions of those with you. What I do want to go through is I want to go through one more problem solving question with you. So find the equation of the perpendicular bisector. So bisector just means you're cutting it directly in half, of the line joining the points 0, -4 and 6, 5. All right, so I'm just going to quickly draw that for you. So we've got our first point here at 0, -4, and we've got our second point here at 6, 5. And what we're trying to do is we're trying to find the perpendicular bisector of that line joining those 2 points. So the first thing that I'm going to do is I'm actually going to work out the gradient of this little line segment here. So we're going to do that using the formula that we've been using for a while now. So the gradient of the line is going to be the difference between our y points divided by the difference between our x points. Let's substitute that in. So I'm going to call this my x2, my y2, and this is going to be my x1 and my y1. So it's going to be 5 take away -4, and then we're going to have 6 take away 0. So that's going to be 9/6, which is going to be 1.5. Actually, let's just leave this as a simplified fraction. So we can divide both by 3. So we'll just leave that as 3/2, because this is going to make it a little bit easier in working out the reciprocal negative gradient. All right, so really simple way to do this. We can do it using the formula. I'm going to be cheating, and I'm just going to do the negative flip. Ready? So the gradient of M2 is going to be equal to -2/3. Boom. Lazy cheat. We love a lazy method. Okay, and now the other thing that I need to do is I need to find this particular point here where it's going to be crossing through. Now that's going to be a little bit difficult to do. So to find this y-intercept, what we're actually going to use, we're actually going to use this piece of information here, because we know that these lines both intersect at this particular point here. So we can use this point of intersection. So how do we find that? Well, that point of intersection, because we're cutting this line in half, is going to be the midpoint here of this red line. So how do we find the midpoint of a line again? Well, we've got to use our formula, don't we? So that's going to be our x1 plus x2/2, and that's going to be my x coordinate for my midpoint, and then the same thing with my y coordinates. So that's going to find me the midpoint of the y coordinates. Excuse me. Losing my voice, I'm talking too much. All right, so the first one we're going to do 0 plus 6 divided by 2. And then for our y coordinate, it's going to be 5 plus -4 divided by 2. So we're going to be left with 6 divided by 2 is 3. And then for this one is going to be 0.5. So we know that both of those lines are going to cross through at this point here. So I'm going to use this midpoint and I'm going to substitute that into an equation. Now we know that the perpendicular line has a slope of -2/3. So let's substitute in our value for x and y to find c. So 0.5 will be equal to -2/3 times by 3 plus c. Now -2/3 times by 3, those are going to cancel, and I'm going to be left with -2. If I add -2 to that side, I'm going to be left with c is equal to +2.5. So the equation of this perpendicular line is going to be y is equal to -2/3 x plus 2.5. And we could put this in fraction form because I do like the fraction form a little bit better. Okay, so that was our problem solving question. So now what I'm going to get you guys to go ahead and do is I'm going to go ahead and get you to practice these questions from chapter 3.6 on page 101. So these are the more difficult questions. And with these ones, if you are having difficulties, please do email me. That's all we've got time for today. So I will talk to you again next time. Bye guys.